Hi, everybody. Today we're going to talk about how to tell if something is linear or nonlinear, if a function is linear or nonlinear. You have this blank document in your Google Classroom, and you're going to fill that out today as we go along with this presentation. An equation that has a constant rate of change. Rate of change is important here. If it is constant and is the same all the time, then we know that it has a constant rate of change and it's linear. Another thing is each one of these equations on the side here is linear. They can be written in this form, y equals mx plus b. And you probably remember that. It is the slope-intercept form of an equation. And if I can rearrange an equation so that it looks like that, that means that it has a constant rate of change and it is linear. Okay, when looking at a graph, if it's linear or nonlinear, you'll know because you'll see a straight line. If it's a straight line, then you have a linear graph. Nonlinear. If we have a nonlinear equation, then it's not going to have that constant rate of change. You can have something raised to an exponent, you can have square roots, or you can have variables in denominators. So if I have 2 over x, this is nonlinear. But if I have x over 2, this is linear. Okay? Big distinction there. We can't have variables in the denominator, but we can have them in the numerator. Looking at graphs, none of these graphs make a straight line. They're all curvy. That makes the functions non-linear. How can I tell if a set of data points is linear or nonlinear? Well, we're going to look at the patterns that are being formed from the numbers. So I'm going to look at the numbers in the x column going in order and look how the y is changing. How the y is changing. Okay. And it has to be constant. It has to be a constant rate of change for that to be linear. There still is going to be a pattern because it's a function, but if it's not a constant rate of change, then it's not a function, or it's not a linear function. Okay, so if I look at table A, and I look at the pattern that's going on, it's always increasing by 3. That is a constant rate of change. Because the rate is constant, this is a linear function. For table B, there's a pattern. It keeps going up by more each time. You see it goes from 1 to 3, from 3 to 5, from 5 to 7. There is a definite pattern there, but it is not constant. This is not the same pattern. It's not a constant rate of change. So this is nonlinear. Okay, let's look at all of these tables and see if they are linear or nonlinear. Take a few minutes and do that. Okay, let's check your answers and see if you were right. Okay, so A was nonlinear, B was linear, C was nonlinear, D was nonlinear, and E was linear. Okay, all right, I will see you in class. Bye-bye.